Hello student, welcome to our physics discussion, that is physics in a smart way. The last issue with our last video was a formula given to you that in a system, if a system goes through a physical change and the root cause of the change is internal, somehow internal disturbances come up and they make the system to change, then center of mass doesn't change its original plan of motion. So that formula is with us, but we need a bit more time to work on it. Today, or let us say firstly, we consider a case where there are two masses. One is M1, other is M2. There are two masses in the system and we try to find out the center of mass of the whole thing, center of mass of the system, or a two mass system. I'm sorry. Now, coming back to our, we got a situation where we got a two mass system. One is M1, of course, they are point mass like very small. M1, other is M2, but they are not identical. Masses are different. For our convenience, we assume masses to be different. So two masses are there. They are placed on x-axis and they have got a separation between them, that is r. The position of M1 is given in terms of its x-coordinate, that is x1, and position of M2 is given its x-coordinate, that is x2. x2 means from origin to the mass M2. x1 means from the origin to the mass M1. And our job is to find the position of the center of mass. If our job is to find the position of the center of mass, and let us say center of mass remains at this position, and center of mass has got a coordinate, that is x coordinate is xc, then we got a formula and we can immediately find the center of mass. We know that xc will be equal to sigma mx by sigma m. That means sum of all masses multiplied by their x coordinates, or the so-called distances, by the sum of all masses. Literally, that means M1 x1 plus M2 x2 by M1 plus M2. There are two masses, and you know this formula will be giving us. That is a way, and we have already discussed it, and we got the formula. But at present or today, I shall not give any stress to the formula. We try to find out the center of mass for this two mass system in a slightly different way. So for that, I am removing this formula because the formula remains. That will be creating a bit of inconvenience for us. So the formula must be removed. The formula must be removed. Okay. So think of the two masses as if connected by a weightless bar. Think of two masses as if connected by a weightless rod or weightless bar. This thing is a weightless, massless, or weightless, whatever you can say, weightless rod or weightless bar. Okay. So thereby, we assume the two masses to be connected. When the masses are connected, then they give the impression of being looking like a dumbbell. They form a single system somehow. But you know, this connecting bar has got no meaning for us. That is just for our convenience. That is not physically present, in fact. So thereby we have taken these two massless or weightless. And the question is posed to us that practically, suppose we do not know anything about center of mass, but we know about physics. We are in class 11 and all that, but we have not heard of any formula that is dealing with center of mass. So And we are giving this dumbbell-like structure. On the left side, we got mass M1. On the right-hand side, we got mass M2. They are point masses. Masses are different. And the distance between them is R. And we are given a practical problem with our fingers, using our fingers or using a knife edge or using anything to support, where the bar must be supported so that the bar or the dumbbell it remains horizontal, that doesn't tilt towards left, that doesn't tilt towards right. I am again repeating my issue, my question, where at which point this must be supported. You may also tie a thread to this point and connect it to ceiling or something like that. So from where the thing must be supported, a knife edge or a thread tying, or maybe where you can keep the entire dumbbell-like structure on your finger, and you may have done it many times using the pens, pencils, and all that, and some mostly we are unsuccessful, but in some cases we are successful, and the cases where we are successful, you put the entire thing to support the entire thing just on the center of mass. This our common sense says so. If the support is on the center of mass, then the entire thing remains poised. So why it remains poised? And let us say the center of mass is at a distance r1 from the mass m1 and at a distance r2 from the mass m2. We know the thing will be getting disturbed. The masses are having their weights. M1 is having its weight, that is M1G. M2 is having its weight, that is M2G. And already we have gone through rotation and all those things that is there. M1G has got a torque effect or the rotational effect, and the rotational effect or efficiency of M1 is the weight of M1 into distance, normal distance, that is R1, as I have discussed in some videos of central mass. Similarly, M2 that tries to tilt the body in a clockwise direction, M1 tries to tilt the body in an anti-clockwise direction. So when the two tilts or the torque of M1 is balanced with torque of M2, the whole thing remains balanced. So torque of M1 must balance with the torque of M2. Torque is force into momentum or perpendicular distance. So M1G into R1 must be equal to M2G into R2. G getting cancelled, we are considering a small bar rather. So M1 into R1 is equal to M2 into R2. That defines the center of mass. And this is a formula which is very simple and very straight to remember. M1 mass M1 into R1 is distance from center of mass will be equal to M2 into R2. Rather, sometimes some books they try to separate the formula in the form of that is R1 by R2 equal to M2 by M1, but that makes the thing difficult because we clearly see that is 1 and this is 2, this is 2, this is 1. That's reversed. Better way is M1 R1 equal to M2 R2 rather than R1 by R2 equal to M2 by M1. That is true, but it is difficult to remember. So thereby, we know the formula of central mass comes in such a way, or the clue to the central mass comes in such a way, M1 into M1's distance equal to M2 into R2's distance. Let us say we go for a practical case. We go for a practical case where M1 equal to 2 kg, M2 equal to 3 kg, and R equal to 1 meter or 100 centimeter. You can talk in terms of meter, you can talk in terms of centimeter. Rather, I will prefer centimeter here because I do not want decimals to be coming in and slide to come. So, with this data, we try to find out the position of the central mass, means the values of R1 and R2, and all those things. And we know that is very simple and very straightforward. We just put in the formula that is M1 R1 equal to M2 R2. M1 equal to 2 kg into R1 we do not know, will be equal to M2 equal to 3 kg into R2 equal to 2 nano. So that gives us R1 by R2, R1 by R2 equal to 3 by 2. But already you know that R equal to this R equal to R1 plus R2. R1 plus R2 equal to 100 and R1 by R2 equal to 3 by 2. Thinking like a school child, arithmetic, R1 is 3 parts and R2 is 2 parts. 2 parts. Total number of parts is 3 plus 2 equal to 5. For 5 parts, we got R equal to 100. So for one part, 100 by 5, that is 20, and R1 equal to 3 parts, that is 3 into 20 equal to 60, and R2 is 2 parts, and R2 equal to 2 into 20 equal to 40. Just if we are not convinced on this or if we do not catch up with the idea, you just go through my video, run it backwards and forwards. I am again repeating for your convenience. R1 by R2 is given as 3 by 2. So we consider R1 equal to 3 parts, R2 equal to 2 parts. Total number of parts R1 plus R2 equal to 100. But in terms of the parts, R1 is 3 parts, R2 is 2 parts. So 3 plus 2 equal to 5 parts. For 5 parts, we got 100. For 5 parts, we got 100. So for one part, we got 100 by 5, that is 20. And for 3 parts, that is 60. And for 2 parts, that is 40. So thereby, if I remove this small portion here, R1 equal to 60 centimeter, R2 equal to 40 centimeter. So this is 60 centimeter, that is 40 centimeter. And that makes us aware on another property of center of mass. Out of M1 and M2, we know M2 is 3 kg, M1 is 2 kg, M2 is heavier. And when you see the position of center of mass, the center of mass is away from the smaller mass, but it's closer to the larger mass because this is 60 and that is 40. So thereby, we make a property of center of mass, we create a property of center of mass, that center of mass or centroid, maybe that is the first property, centroid leans or shifts, whatever, shifts towards heavier portion, of the system. The mass leans or shifts towards, or is present, you may say it's present towards the heavier portion of the system, because that is a bit of a selfish nature when you compare the central mass to human centimeter like that. That is present near the heavier mass. More heavier the masses are, the central mass will be close to them and away from the smaller mass. So that was our idea. Or two mass system, we ended with the formula that M1 x1 plus M2 x2 by M1 plus M2. We can directly have the formula in the way that M1 R1 equal to M2 R2, and thereby we know that it will be much easier. Say, we consider a two mass system. It's a practical problem because a two mass system, but the masses are not fixed. Initially they are fixed, but they will be free. One mass is M1, that is a point mass, just like the mass M1 we have seen. Another mass is M2, though I have drawn them in bold black fonts, but they are small. They are small means they have no. This, as we are discussing, the two masses M1 and M2, they are initially held at rest and they are suddenly released. release at a particular time, mt equal to 0 or something, at a particular time instant they are released. So when they are released, we know due to the mutual force of attraction, that is gravitation between them, they will be starting to move. They will be starting to move. Initially, separation distance between them was r, 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 and because it's a two-mass system, I'm sorry, it's a two-mass system, it must be having its own central mass. If somebody tries to find out the position of the central mass, if the central mass is R1 and R2 from M1 and M2, then we already do know that M1 R1, M1 R1 equal to M2 R2, M2 R2. So R1 by R2, R1 by R2 will be equal to, that is M2 by M1. M2 by M1, that is the position of central mass. Of course, we do not know what benefit it. So we continue with our story. The masses are released. M1 starts to move towards M2 and M2 starts to move towards M1. And we know that the force of attraction between them will be same. That is Newton's gravitational interaction force. The forces on M1 and M2, they are equal and opposite. We can also, we do know Newton's third law, every action has got opposite reaction. So if somebody considers the force between them, with the help of that force, M1 will be accelerating. So F can be written as M1 into A1. The same amount of force also will be accelerating M2. So that you can write as M2 into A2 instead of writing another line. So thereby, the ratio of the accelerations A1 by A2, if you consider these two, then that will be equal to M2 by M1. I do know that is coming the same ratio as the ratio of the distance of the center of mass. When M1 starts to move, let us say after some time, M1 has got a covered distance, and that distance is delta R1. And M2 has covered distance that is equal to delta R2 or delta X2, whatever you say. So if somebody tries to find the distance, and this will be the new position of M1, this will be the new position of M1, that will be the new position of M2. Now from the center of mass, I do know central mass won't be moving, because if now we got to stop to apply the formula, we have learned in the last class that if a system goes through a physical change, but the cause of the change is internal, then central mass doesn't change its original plan of motion. When we release the masses initially M1 and M2, they are fixed, they are held at rest. But when we release them simultaneously, we remove ourselves from the situation. Now M1 and M2 start to move. If somebody tries to find the cause, why M1 and M2 are moving? You know the M1 and M2 are moving is due to the internal gravitational force between them. M1 is pulling M2 and M2 is pulling M1. So the cause of the motion of M1 and M2 towards each other is internal. M1 is pulling M2, M2 is pulling M1. Somebody from outside doesn't do all those mischief. So thereby center mass says, before the M1 and M2 they start to move, at the initial instant they are at rest. So center mass will be at rest. And when M1 and M2 they start to move towards each other, center mass says, why you are moving? M1 M2, if they are prepared to answer, they will say that M2 says M1 is pulling me inwards, M1 says M2 is pulling me inwards. So thereby central mass says, you are moving due to your internal disturbances. I am not to change my original plan of motion. My original plan of motion was to stay at rest, just at the initial instant. So I will be staying at rest. I won't be moving. Even if you may be interested to move and you are moving. So here central mass will be at rest, and M1, M2, they're moving in such a way that if the distance of the central mass from M1 is x1, distance of the central mass from M2 is x2, the formula will be always valid M1 x1 equal to M2 x2. Or if we go for a change in R1 R2, we know R1 by R2 equal to M2 by M1. When R1 goes through a change, that becomes delta R1. When R2 goes through a change, the change of R2 is delta R2. So that will be equal to your also M2 by M1, M2 by M1, because we can take this formula and we can differentiate it. When you differentiate it, M1 and M2, they are not to change. Only R1 will be changing as dR1 or delta R1. M2 will be changing as delta R2 or dR2. So thereby, it will be holding that relationship. We know this is, and once M1 M2 we allow some time to pass, M1 and M2 must be having their velocities. M1 is moving with the velocity v1, M2 is having with the velocity v2, and you know velocity is nothing but derivative of the position vector, derivative of the displacement. So thereby we know v1 by v2 will be equal to v1 equal to dr1 by dt, v2 equal to dr2 by dt. And because you know the result, that will be equal to m2 by m1. That is equation number 3. If you make a further derivative, velocity becomes acceleration. The ratio of the acceleration will be also the same thing that already we have found out in this case. That is a1 by a2 equal to m2 by a1 by a2 equal to m2 by m1. Okay, so many things they are interrelated, but here formula or our idea or the solution starts with the idea that if a system is going through a change and the cause of the change is internal, then centroid or center of mass won't be changing its original planar motion. Initially, before the masses they have started to move, the center of mass was at rest, and because center of masses are moving due to the internal causes and internal causes, mutual gravitation between them. Nobody from outside compels them to move. So central mass will be remaining at rest. That was the initial posture of the central mass, and central mass will be staying at rest. So masses will be moving in such a way that their velocity, their displacement, and acceleration will be in the ratio. And in every case, we see that is m2 by m1, m2 by m1, ratio of the displacement, ratio of the velocity, and ratio of the accelerations. Okay. The same case also will be seen if we do not take this thing, but let us say we got m1 and 2 are there, and we are dealing with a massless spring. We are dealing with a massless spring. The spring is initially long, and we have kept M1 and M2 bit compressed, M1 and M2 bit compressed, sorry, bit compressed, and initially they are kept in a position like this, but they are in a compressed position. Maybe you can bind them with the help of a thread because it is difficult to keep the spring in this compressed position. So when they are kept at rest in such a way, the distance between them is r. And you know, if somebody is interested in finding the position of center of mass, this will be R1, that will be R2. The spring is supposed to be massless. The spring is supposed to be massless, and M1 R1, the same formula is valid, that is M1 R1 equal to M1. Now, suddenly, the string that holds the masses in place is caught, or if somebody is holding M1 and M2 at their places, they suddenly remove their hands at the same time. So when suddenly they remove their hands at the same time, we know the masses, they will be starting to go out because initially the spring was compressed. So when the masses go out, if after a time the M1 has got a displacement that is delta x1, M2 has got a displacement that is delta x2, we know the ratio of the delta x1 by delta x2 will be just like delta R1 by delta R2, that is W by M. If this mass has got a velocity v1, this mass has got a velocity v2, we know the ratio of the velocity will be following the same pattern just like the last case, because in this case, before we move our hands and before we cut down the string, the central mass was at rest, and the masses are moving out away from each other because the spring is compressing them, and spring is an internal agent. Nobody from outside forces the masses to move out. So because the spring is pushing the M1 to go like this and pushing M2 to go like this, and spring is internal to the system. So thereby central mass will be remaining at rest and central mass won't be moving. The masses will move in such a way. The ratio of their displacements, ratio of their velocity, and ratio of their accelerations, because the same spring force is pushing M1 and pushing M2 will be always M2 by M1. That is the idea. Next class, next video, we will be considering another interesting case. Thank you for today. Today's video has been long. Thank you again.